Okay, here's the second video, picking up right where we left off. Number 8, it says graph this standard form equation. Again, you could do x-intercepts and y-intercepts, and the quickest way of doing it would be x and y-intercepts by simply covering up. See, to find the x-intercept, you set y equal to 0, so you could just cover that up, and you have a simple one-step equation here, 6x equals 12. So you would divide by 6, divide by 6. That means that your x-intercept is x equals 2. It's going to cross the x-axis at 2. Okay. How about the y-intercept? Well, to find the y-intercept, you set x equal to 0, which means you could just cover that up and solve for y. So here we go. Let's solve for y. Divide by 3, divide by 3. Your y-intercept will be 4. Your y-intercept will be 4. Okay. Or you could write y equals 4. Or you could even write the coordinate 0, 4. Over here we should have written the coordinate 2, 0. Anyway, which of these graphs crosses the x-axis at 2 and the y-axis at 4? This one crosses at 3, this one crosses at 2, but it doesn't cross at 4. So we know that it needs to look like this. It crosses the x-axis at 2, and it crosses the y-axis 1, 2, 3, 4 at 4. Right? So your line looks like this. Which one of those looks like that? That would be this one right here. That's why it's green, right? Crosses at 4, crosses at 2. So you could find the x and the y-intercepts quickly just by covering up your x, solving for y, then covering up your y, solving for x. Let's move on. So on this equation, they're asking us to graph, but the bottom line is it's not in standard form and it's not in function form. So it's totally up to you how you want to graph this. I would just move the 2y over by subtracting 2y and writing it in standard form, right? Again, standard form is capital AX plus capital BY equaling capital C, where A, B, and C are just numbers, no fractions, no decimals. So let's begin by doing that, subtracting 2y. That'll cancel out. Subtract 2y. You can't really subtract y's from x's. They're not like terms. So we're simply going to rewrite it. 4x minus 2y equals negative 8. Now this is in standard form. Now we could find the x-intercept and the y-intercept. Okay, so to find the x-intercept, we set the y equal to 0 and solve. To find the y-intercept, we set x equal to 0 and solve. So you could actually show this work, right? So let's set the y equal to 0. So that's going to be 4x minus 2 times 0 equals negative 8, right? And obviously the negative 2 times 0, that's 0, it eliminates. So you really have the 4x equals negative 8. And you could divide both sides by 4, right? Dividing by 4, dividing by 4. That'll give you x equals negative 2. So your x-intercept is at negative 2. X-intercept is at negative 2. Now, instead of showing your work, you could always just, since you are setting x equal to 0, you could just cover up your x term, right? So you could just cover up that x term, and you'll see the simple one-step equation there, negative 2y equals negative 8. Well, you would divide by negative 2, divide by negative 2. Negative 8 divided by negative 2 is positive 4. So you will know that your y-intercept is at positive 4. It crosses your y-axis at positive 4. Okay. Of course, if you're kind of struggling with that, please show your work instead of just covering it up and solving. Please show your work the way we did right here. Anyway, we know that it crosses the x-axis at negative 2. So I'm going to put a blue dot right there, and it crosses the y-axis at positive 4, way up there, and I'm going to put a red dot up there. So we know that our line goes like that. It should look like that, and as you can see on all of these options, none of them look like that. So none of these would be the correct answer for this question. Let's move on. On this question, we have a function form equation. Y is by itself, function form, and we know that function form is amazing because it's like a machine, and you could do an input-output table, an XY table, and most of the time we use 0, 1, and 2. However, that's not the best option for this particular one. Why is that? Because we have a fraction in front of the x. So yeah, plugging in 0 is awesome because 0 times 1/4 is 0, and 0 minus 5, that'll just be a minus 5. So that gives you a beautiful coordinate 0, -5. But if you plug in a 1 right there, you're going to have 1/4 minus 5, and that's going to give you a ugly fraction. You don't want fractions, especially when you're graphing. It's nicer to have integers, nice whole numbers, right? Positive or negative numbers. So we don't want fractions, we don't want decimals. So obviously, when you have a fraction and you multiply by its denominator, that's when the fraction disappears. So it would be nice if that x, instead of a 1, if it were a 4, okay? And then besides that, it would also be good to do the denominator but times 2. So maybe instead of just a 4, an 8 would also be great. Hey, an 8 is great. Okay, so because 8 divided by 4 is 2, and that will cancel out and you end up with a nice whole number. So 0, 4, and 8 would be great options. Not 2, but 8, okay? Now let me actually show you how 4 works beautifully. Here's my equation, and we're plugging in the input 4. Now watch this, the 4 and the 4 disappear, so what I really have is a 1 minus 5, which equals -4. So for the input 4, I get the output -4. That's a nice coordinate, 4, -4. That's awesome, right? If I do plug in that denominator 4 but doubled, that would be an 8. The input 8 will also work out beautifully. Let me show you that. Here's my equation, and I am plugging in an 8 this time, and of course the 8 and the 4, 8 divided by 4 is 2, so you really have 2 times that 1, so 1 times 2 is 2. So I have y equals 2 minus 5, which means that y equals -3. Okay, so -3 is my output for the input 8. So as you could see, plugging in 0, 4, and 8 is the best option. You don't want to do 0, 1, and 2 because you end up with fractions. You don't want to do 0, 5, and 10. You don't want to do 1, 2, and 3. 0, 4, and 8. Another good one would be 0, 4, and -4 because you could plug in that denominator but negative, and that'll also eliminate it, but it'll just change the sign. So keep in mind, whenever you do have a fraction in front of x, since you are multiplying a fraction times x, let's use that denominator to be x. That way it'll cancel out the fraction. Okay, so 0 always works. 4, which in this case is the denominator, and 8, which is the denominator but doubled. That's a great option. Let's move on. Find the corresponding outputs for the given input 0, 2, and 4. So we have a function machine here, a function form equation, y is by itself, and they're telling us to do the inputs 0, 2, and 4. Remember, a function's like a machine, and they're telling us specifically to put in the number 0 right there, work it out, get an answer, get an output. Plug in the number 2 right there, work it out, get an answer. Plug in the number 4 right there, work it out, get an answer. So find the corresponding outputs, find the answers to the given inputs. You want to find the y values for the given x values, right? So let's do that. Let me plug in a 0 first. So here's my equation. Y equals 1/2 x minus 5, but instead of x I put a parenthesis, and I'm going to input the 0 right in there. Okay, I'm going to plug it in. So anything times 0 is 0, and 0 minus 5 is -5. So my first output, okay, my first output is -5. Okay, so how about the next output? Well, let's plug in the number 2 right in there. So let me write my equation again, but this time in x, I'm going to plug in the 2. The 2 is going to go right in there. So I have a 2 right in there, and of course it's great when you have a fraction times its own denominator. That eliminates. So the 2 and the 2 cancel out. What I have left is a 1 minus 5. 1 minus 5, that will be -4. So my next output is -4. And finally, for my last output, I need to plug in a 4 right in there. So let me rewrite this one more time. And this time I'm going to plug in a 4 right in there. So I plug in a 4. And of course, you could cancel first and then multiply, or you could multiply first, then cancel. I'm going to multiply this time. 4 times 1 is 4. And 4 divided by 2 is 2. Minus 5, that'll give me a -3. Okay, so my last final output should be -3. So I'm looking for these outputs right here, -5, -4, -3. I have a -5 and -4, but that's not a -3, so that's not it. And actually, that's none of these, right? None of these are the correct answer. What you should have seen is -5, -4, -3. There are a lot of none of these on this practice. There probably won't be that many on the actual quiz. Let's jump to the next question. Rewrite in standard form. What is standard form? that would be capital AX plus capital BY equaling capital C, where A, B, and C are numbers, actually integers, which means no decimals, no fractions. So as you could see, this is in function form. The y is by itself. It has a fraction. In order for us to get the standard form, let's first begin by getting rid of this fraction. How do you get rid of a fraction on an equation? Multiply everything by the denominator of the fraction that you want to get rid of. So times 2, that'll eliminate the 2's, times 2 times 2. Multiply everything by 2. So my new equation is 2y equaling, what do I have left right here? I have a negative 1 with an x. Negative 1x. And last but not least, the 3 times 2 is 6, so plus 6. So it's almost in standard form. At least I don't have any more fractions, but my standard form equation has to have my x and my y on the left side of the equal sign. X and y on the left side of the equal sign. So here's my y on the left side, but I need this x to go over here to that left side as well. So I need to get rid of that minus 1x by adding 1x. And adding 1x. And of course, you can't really add x's and y's. They're not like terms, so you're just going to rewrite it. Let's do our x term first, alphabetical order. Write 1x first plus 2y equals 6. Okay, that's all that's left on the right side, just the 6. And yes, I could put a 1 if I wanted to, but it's really not necessary. I prefer you not to. Whenever you have a 1, you don't even have to write the 1. Just write the x. Obviously, there's only 1x here. So this is the standard form equation that you're going to type in with no spaces between your terms. X plus 2y equals 6. X plus 2y equals 6. Getting to some graphing equations, and we do have them in function form. Y is by itself, and whenever you do have a fraction, again, I do recommend you to not use 0, 1, and 2. Always use 0, because whenever you plug in a 0, that'll become 0, and this number will be your output, right? So plug in 0, 1/2 times 0 is 0. 0 plus 2 is 2. So 0, 2 is a coordinate. So maybe instead of looking at my multiple choice answers, I'm just going to go right here to a x, y graph and go to the coordinate 0 on the x, 2 on the y, and I'm going to put a dot right there, okay? Now, I need another point to graph this thing, another point. So I need another input. Now, if I plug in a 1, then that would be 1/2 plus 2, and I'd get 2.5. So that's not really that nice to have 2.5, especially on graphs. So let's go with plugging in another nice input, which would be the denominator of the fraction, because if you did plug in a 2, it would cancel out and you'd have no more fraction. So let's plug in a 2. And when I do plug in a 2 right there, 2 and 2 cancel out. You'll have 1 plus 2, which equals 3. So the next nice point would be 2, 3. 2 on the x, 1, 2 on the x, 3 on the y, which would be right here, okay? 2 on the x, 2 on the x, 3 on the y, it'd be right there. So our equation, or our line, looks like this, okay? It looks like that. Crossing the y-axis at 2, and also going to the coordinate 2, 3. So which one crosses at 2? That one doesn't cross at 2. That one doesn't cross at, that one doesn't cross at 2 right there. This one crosses at 2, but it's going down. It's going down instead of up. So that's not it. And that one's also not it. So yes, none of these is the correct answer to this one. Okay, none of these. Okay, this is what it should look like, and obviously none of those look like that. Let's move on. Once again, we have a function form equation, and it's pretty simple. Just go for an input-output table, and since there are no fractions in front of x, you could use 0, 1, and 2. That would give you 3 points. All you really need is 2 points. But let's actually plug in the 0 right in there. That will read y equals 0 minus 2. And 0 is nothing, and 0 minus 2 is minus 2. So that would give you the output of negative 2. The input 0 gives you the output negative 2. How about the input of 1? What does it give us? Well, let's plug in a 1 right there. What is 1 take away 2? 1 take away 2 is negative 1. So the input 1 gave us, when you put in a 1 right there and you do the math, you get the answer negative 1. So the x value of 1 gave us the y value of negative 1. Okay. Now let's plug in a 2 right there. What's 2 take away 2? That's 0. So put a 0 right here. And those are your 3 coordinates. And what should that look like? Well, it should look like, well, actually we could see it right here. 0, negative 2, 0, negative 2, that's that dot right there. 1, negative 1, 1, negative 1, that's that dot right there. And 2, 0, 1, 2, not up or down, it's 0 on the y. So these 3 dots, this line is the correct answer.